Hey everyone, welcome back to another video by Camroom 5. We know that in the periodic table of elements, group 1 is the alkali metals because they make alkaline solutions. Lithium, sodium, potassium are the most common alkali metals. They had one electron in the last shell. While group 7 is known as the halogens. All the halogens in group 7 have 7 electrons in the last shell. So when we focus on halogens, we come across fluorine, chlorine, bromine, iodine, and astatine. These are group 7 elements. Fluorine, I'm highlighting them each with a particular color because we are going to talk about their colors also. The first element is fluorine. So fluorine is actually a pale green gas. We write them F2 because there are always two atoms together in a diatomic molecule. Next comes chlorine. Chlorine is in period number 3. So we know they have 3 electronic shells, right? We know how atomic structure is connected. We write chlorine, chlorine, Cl2. We always write Cl2, never write Cl because they always exist as diatomic. Next comes bromine in period number 4. So it has 4 electronic shells, and group 7 means it has 7 electrons in the last shell. Each atom has 7 electrons in the last shell. So bromine, Br2. Bromine is an orange brown liquid. So the molecules of bromine are closer compared to the molecules of fluorine and chlorine. Next is iodine. Iodine is in period number 5, group number 7. Iodine, it is a gray-black solid, which means the diatomic molecules of iodine are even more closer. Last is astatine, At. It's not a very common halogen, but it's good that we know about it. Astatine, if you can follow the trend of the colors, you can predict that astatine would be even more darker in color. So astatine is At with 2, which means diatomic. It's a black solid. Let's recall the halogens fluorine, chlorine, bromine, and then iodine. We know that each one of these has 7 electrons in the last shell, so they make diatomic molecules. We can see few apparatus here on the screen. On the left you can see 2 gas jars. On the right you can see a round bottom flask, and then you can see a china dish. Fluorine is a pale yellow gas, which means the particles are irregularly arranged and they are constantly moving in random directions. Chlorine also a gas, which means diatomic molecules of chlorine are again no regular arrangement and gaseous nature. Bromine is a red-brown, orange-brown liquid, which means again the particles are not regularly arranged, but there is clusters of molecules. Last is iodine. You can see a gray-black solid with violet vapors. The vapors are violet in color, and it's appropriate to call it violet, but you will see purple color also here. So fluorine is a pale yellow gas. Chlorine Cl2 is a pale green gas. You will see normally the word fumes with them, so fumes is also okay. Bromine is an orange brown liquid, so particles are arranged in clusters here. And then iodine, I2, is a gray black solid, and then you can see violet vapors of iodine. When you heat it slightly, iodine begins to vaporize, so you will see violet vapors around it. If we talk about the molecular arrangement, you can see in fluorine the diatomic molecules are in gaseous nature, lying away from each other, irregularly arranged. Similarly in chlorine, but you can notice the molecules are bigger here. Why? Because each chlorine atom is bigger. Each chlorine atom has 3 electronic shells in it. So that is why the overall chlorine molecule is bigger than overall fluorine molecule. Now you can notice that bromine molecules are even bigger because bromine atoms are even more bigger, but the arrangement of bromine is liquid. So you can see the clusters of bromine molecules which have their irregular arrangement, but they are not like gaseous molecules. They are liquid in nature. Bromine atoms are bigger than the other two. And last comes iodine, and now you can see iodine has a regular structure. Because iodine molecules, the I2, are arranged in solid structure. We call it simple covalent molecule, but they make a solid lattice. Let's recall the trends between fluorine, chlorine, bromine, and iodine. When we say the word down the group, we mean starting from fluorine and then ending at iodine. So one thing is for sure that the atoms are bigger, but let's write about color that the color intensity increases. You can see the color becomes more and more darker from fluorine to iodine. We don't have to talk about the reason right now, but we just know the trend. Another is the melting point increases. You can see that fluorine and chlorine are gases, and then bromine is liquid, iodine is solid. So this is because intermolecular forces also become stronger. Intermolecular forces increase. The iodine molecules are more closer to each other than fluorine. The last trend is their chemical reactivity decreases. Fluorine is very reactive. Fluorine will react very violently with other elements, but iodine doesn't react as violently. So remember, the chemical reactivity decreases. It is very opposite to group 1. In group 1, the chemical reactivity increased down the group. But here the chemical reactivity decreases. Fluorine is very reactive, iodine is very less reactive. Let's recall their chemical properties, and when we say chemical properties, let's recall how they behave chemically. We call them halogens, by the way, because halo means a salt. So halogen means salt producing elements. They make salts generally. They have 7 electrons in last shell. When we say last shell, we mean outermost shell, obviously. So fluorine, chlorine, and like all these halogen atoms have 7 electrons in the last shell. Fluorine's configuration is 2,7. Chlorine's configuration is 2,8,7 because chlorine has 3 shells. And similarly, bromine, iodine, and astatine. All they have 7 electrons in the last shell. I'm not writing whole configuration, but we know that there are 7 electrons in the last shell. You can see that their valency is 1. So they gain 1 electron to make a complete anion. They gain electrons and they become negative ion. Remember, anions are negative ions. So fluorine wants to gain an electron and become fluoride. But remember, fluorine is never alone. There are 2 atoms. So they gain 2 electrons, 1 for each, and then they produce 2 fluoride ions. So fluorine molecule gains 2 electrons, where each atom gets 1, and they become fluoride ion. Similarly, a chlorine molecule will gain 2 electrons. Each atom gains 1, and they become 2 chloride ions. Bromine gains 2, become 2 bromide ions, and iodine molecule gains 2 electrons to form 2 iodide ions. These ions are negative in nature. We call them halide ions. Halide means that whatever the halogen is, it has IDE in the end. Chloride, bromide, iodide ions. In electrolysis, they will go for the anode always because they are negative ions. Remember, gaining an electron was reduction, so the halogens reduce themselves and make negative ions. They can make one covalent bond if they are reacting with nonmetals. Because remember, nonmetals will never lose electron, nonmetals will never make cation and ion. So with nonmetals, they make covalent bonds where they share one electron. So going for their chemical bonding, they can perform ionic bonding with metals and covalent bonding with nonmetals. In ionic bonding with metals, the group 7 halogens make halides, which are negative ions. So they go with positive ions and make a compound like sodium, magnesium, calcium, iron, and copper. They are metals. So these metals will make ionic bonding. Like sodium has a plus ion, so sodium will make sodium chloride, sodium bromide, sodium iodide, where each halogen is actually a negative ion and the metal is obviously positive. With magnesium, they make magnesium chloride like MgCl2, MgBr2, or MgI2. Magnesium bromide, magnesium iodide. Calcium also has a plus 2 charge, so similar pattern of chemical formula for calcium chloride, bromide, and then iodide. Iron could be iron 2 plus or it could be iron 3 plus, remember? So let me write it correctly, yeah. Let's write it with a distance, iron 2 plus or iron 3 plus. Iron 2 plus can make a compound with FeCl2 because each chloride would be minus 1. But in iron 3 chloride, it would be FeCl3 to just balance off the numbers, right? Similarly, copper could be plus 1 or copper could be plus 2. With copper plus 1, the formula goes CuCl. With copper plus 2, the formula goes CuCl2 to balance off again the charges. In simple covalent molecule, they make one covalent bond with each. So for example, carbon makes 4 covalent bonds and it can make CCl4, carbon tetrachloride. Hydrogen makes only one covalent bond. So one halogen will make one bond with hydrogen and you can call it like HCl, HBr, HI. So because hydrogen makes one bond and halogen also makes one bond. Sulfur makes two bonds. So each chlorine will make one bond and you can get SCl2 or you can get SBr2 or you can get Si2. So you have to follow the pattern of how halogen makes one bond each. I hope this idea is clear to us. In the next video, we'll talk about the halogen displacement reaction. Stay tuned guys. Thanks.